Hello class, today I will be teaching you about conic sections, and you've already seen the video and you've already seen the demonstration of what a conic section really is. As the word suggests, you even know that conic sections are really indeed related to a cone, okay? But now we're going to talk about the first conic section called the parabola. And we already know what a parabola is, right? That's what you're thinking right now, right? You're like, okay, I know this equation. This is the vertex form of a parabola, right? This is the vertex form of a parabola. And you also know that what a parabola really looks like. You know that it looks like this, right? You know that it could be smiling or it could be sad and frowning, and a is greater than 0, or when a is greater than 0, you know that it looks like this, right? And you know that it's in terms of x, that means y is and x is squared. Okay, so you know all that already. So you're thinking, what more do I need to learn about parabolas? But before we do anything more, what I want to share with you is a definition of a conic for reals, okay? Word for word, what a definition of a conic is. It's a locus or a collection of points satisfying a geometric property, okay? So locus means it's just a collection of points, okay? Now, so what is a parabola? And this is going to show you how we can actually use the definition to actually create a parabola. So here, parabola is a set of all points x, y that are equidistant from a fixed line, which is called the directrix, fixed line, which is called the directrix, this is important, directrix, and a fixed point focus, not on the line. Okay, so what does that mean? It means I have a fixed point called the focus, I have a fixed line called the directrix. Now, there is kind of a collection of points in which I can actually, so like for example, if I draw a line perpendicular from this, there is a point that's equidistant from here and here, which is right here. They're equal here. They're equal here and here, and that's, there's more points that are equidistant, and if I connect those, that's going to form a collection of points, and if I actually trace the line, it's going to create a parabola. And I'm going to show you that right now with a demonstration, okay? So watch this. Let's say I have a fixed point, which is called a focus. So I'm going to draw a focus. This is called my focus. And you'll see that it's not so easy to draw this, okay? And I'm going to draw a directrix, okay? I'm going to draw a directrix. I'm just kind of estimating here. Of course, I can't get it exact since I'm actually just drawing it by hand, okay? Now, I know somewhere in here, if I draw this perpendicular line from it, okay, there is a point that's equidistant from here to here, so that's one of them, okay? I'm going to draw another one. Maybe if I go like from here, just kind of estimate from here, maybe to here. Oh, that looks pretty good, okay? That's another point, okay? Maybe another one on this side. Maybe from here, I don't know, look at that and look at that length. Oh, it looks pretty good, okay? So here is equal, and here is equal to this, right? So I'm going to put a point there, okay? Let's try another point, okay? Maybe I'm about to stretch it out a little bit. Oh, that looks pretty good, okay? Like these lines are equal. So that's equidistant from the focus and the directrix, okay? Let's try another one right here somewhere. That looks pretty good. Maybe like that? I don't know. I'm just estimating, but just you get that general idea, right? Now, what if there were more lines equidistant, which exist here? They do. But with our human hand, we could only do, we'll just estimate. And if I continue this pattern, right, and I connect these points, the locus of points, what am I going to achieve? Oh my God! That's a parabola! Exactly. It's a locus of points which are equidistant from the focus and the directrix. And if I connect them, I form a parabola, and that's a parabola. Okay? So you can see that directrix is always behind the parabola, and the focus is always inside of a parabola. And what is this guy called? Yup! Your classic vertex, okay? So let's actually go back, and I'm going to show you all the parts of a parabola, all right? But now, before we do that, I want to share a couple more things with you, okay? Let's go back to this page of notes, okay? Now, you're used to this, right? But I want you to know that there are other special parabolas that can move sideways from left to right and left to right, left to right. So I could tip this over, and it's going to go that way. I could tip this guy over this way, rotate this guy, and he's over here. So look at this equation of this parabola. What's so strange about this? What's the difference? Think about that. And I'm just going to tell you that this right here is going to form a parabola that goes left and right. And look at what you should notice is that y is squared here. And our typical one is x is squared. And a is less than 0 if it's going to the left. A is greater than 0 if it's going to the right. All right, so let's go to part 1, parabola and all of its parts. Okay, so I'm going to demonstrate to you all the different parts of a parabola that you need to know. Okay, so you know what this is a parabola that we've constructed. Okay, something like this, right? Okay, can you see this? Okay. All right, and it's also a better picture here. Here's your vertex, here's your directrix. Remember, this is a collection of points that are created. It's a collection of, parabola is nothing but a collection of points that are created when it's equidistant from the focus and the directrix. Okay, now the vertex, you already know it's HK. That's what you've always been taught, right? Hong Kong, or HK, which stands for the vertex points. Okay, now, the focus is inside of the vertex. Isn't it related to the vertex? And that distance that's equal, we're going to call that guy P. Okay? It's P distant here, P distant here. Now, tell me about the focus. If I was to put a coordinate for focus, what would you write that as? Did the H coordinate or the X coordinate change at all? No. So we keep that guy. How about the K? Did the K coordinate change? Yes. It moved up P. So we're going to go K plus P. How about the directrix? Well, the directrix is actually a line. What kind of line? For this kind of parabola, it's a horizontal line, right? That means it's going to be a y equals what? Is it going to be using the H or the K to write in terms of P? It went back P, but it's not H, right? Because X coordinates stayed the same, but it's our K. So it's going to be K minus P. So if this were a 5, this would be, and this P was 3, it'd be a 2 here, right? Okay, so that would be that. You don't need to memorize these, okay? Because you'll know from common sense. For example, if I gave you one like this, okay? If I gave you one like this, and I told you this, you know that this guy is my vertex, this guy is my directrix, right? This line, okay? Yeah, and it's all, in this one, in this case, you would have to add P because it went up higher. This guy, you would have to go down to the focus, all right? All right, but how about the other case, right? How about the other case of the parabola where you have left and right? So for example, this kind of parabola. In this case, let's say our focus is here. Let's say our directrix is here, right? And this is our classic vertex, right? Our HK. Then what would be my focus? Try to write the coordinate right now. My focus is here. How would I write my focus? And this is my directrix. How would that change in comparison to my up and down parabola? All right, so H moved a little bit P, right? It's P distant away, so H plus P, but the K stayed the same. The Y coordinate stayed the same, right? The directrix is no longer a Y equals a horizontal, it's a vertical line, so it's going to be X equals what? It went back a little bit, so it's going to be H minus P, okay? So try to digest that and ask questions if you have any. All right. So now, as with every graph that we ever talk about, okay, you're going to have to know the STD form. There's an STD form, okay? Now, there's an equation for a parabola that you're already familiar with. Y equals, right, A, x minus h squared plus k. That's for your classic up and down parabolas, right? But now we're going to write a different variation of that. And that variation, it looks like this. That's our regular. Okay, and I'm going to explain to you what our 4P, this 4P strange thing is, okay? Now, so there is a can you see the relationship between these two? I'm sure we're all good enough where we can actually derive this guy from this guy. Okay, except the P and the A are strange, but we'll see the relationship later. Now, that's our regular. What if we have a sideways parabola, right? It would change a little bit. Okay, what would change though? Right? In this case, you're right. X is squared. Okay? How about here? Yes. Y minus K. And how about here? X minus H. Same, but a little different. Okay? Who's squared? Y is squared. Okay? But it's not very different. Okay? Now, it's always 4P here. Now, but how is it from here that it got to this, right? So I'm sure a lot of you guys have already figured it out, but we're going to subtract K, right? Y minus K. Oh, we're getting really close already. already, right? We're getting really close. Look, look, look. Y minus k. And we're going to get rid of a because we're going to solve for x minus h. So I'm just doing one of the cases. So 1 over a, y minus k is equal to x minus h squared, right? Pretty good, okay? All right, now we're done pretty much, right? So then what can we conclude? Oh my God, there's so much relationship here, right? Okay, so what can we say about 1a? 1a must be 4p. So what can we say about a? A must be 1 over 4p, okay? And we can solve also for p, right? We can also solve for p. So p is also equal to 1 over 4a, okay? So just have to keep those kind of things in mind, all right? Now, what if I told you that our vertex HK is at the origin? How would this guy change? We'll plug in 0, 0, 0, 0. What would that be? It would just become this, okay? So if it's a origin, look who's squared. Y is squared, so you know it's going to go this way or this way from the origin, which means HK is equal to 0, 0. And here's the same shape. Y, x is squared, so you know it's going to go up and down. Okay? And that's our regular. All right. So how do you feel? Ask yourself that. Let's try some. Okay, you guys.